Good morning, everybody. We're going to finish up chapter 3 today, and the topic that we're going to be going over is inverse functions. So this word inverse right here means to do the opposite. It means to undo something. And so some examples of some inverses here would be like addition and subtraction. Those undo each other. There's multiplication and division. So multiplication and division. There are powers and roots. So like if something is to the second power, you take the square root to get rid of it. And so we're going to be talking about what that looks like with functions today. So as a reminder, a function is just a rule. You can almost think about it as a machine where you've got an input. So like here, if our function is y equals 2x plus 3, the input here, if we plug in 1 for x, that's going to give us y equals 2 times 1 plus 3, which will be a y value of 5. So the output here would be 5. Now, an inverse says that if we punch 1 in and we get 5, if we punch 5 into an inverse function of it, which you can start to look at this and tell that these two are inverse functions because there's a multiply by 2 here, there's a divide by 2 here, there's a plus 3 here, there's a minus 3 here. So if we put 5 in and we go into the inverse function, if we do 5 minus 3, that will give us 2. 2 divided by 2, we end up with 1. And so that's kind of a way to check if two things are inverses or not. So the way that we write notation for inverses. So like if f of x equals 4x plus 1 there. So remember, f of x stands for a function of x. Now the inverse here, the notation for inverse is f of x, but we have that little -1 there. The -1 there signifies that we've got a inverse possible. So just to write this down so I can eyeball, I'm at the point where I can eyeball these and tell you what the inverse would be. I'm just going to write it real quick. We'll talk about how to solve for 1 here in a sec. That's going to be x minus 1 divided by 4. So that would be the inverse function of 4x plus 1. So graphically, the way that you find an inverse, to identify what an inverse is you're going to reflect across the line y equals x. So just as a reminder of the line y equals x, that's just a line with a slope of 1 that passes through the origin here. So it's going to be this line right here that we're reflecting over. And to reflect over y equals x, like let's say we had a point here at -2, and we'd measure the distance to the line here, and then we'd measure that distance out. So give or take the rough reflection here. So if it's 2 away from this line for the y value, we're going to go 2 to the right for the x value. Like these would be reflected because they're the same distance from this line. Now, algebraically, when you find an inverse, what you do is that you switch x and y. And so basically what that means, so if the domain of your original function, the domain of f of x, is going to become the range of the inverse. And the same thing for the range. The range of f of x is going to be equal to the domain of the inverse. Because when you find a inverse, what you have to do really to do that is to check and see or switch the x and y values. So when that domain, when you switch it to a y value, it just becomes the range. Now, the other things here, only one-to-one functions have inverses. So what that means, so a one-to-one function means that for every x value there is, is that you only have one y value. And so in this section earlier, we talked about the vertical line test to test if something is a function. And if you think about what the inverse of a vertical line is, it is a horizontal line. So the way that we're going to be testing to prove if something has an inverse or not. So to prove it's a function, you have to do the vertical line test. To prove it has an inverse, because only a one-to-one function has an inverse, you're going to run a horizontal line through it, and it should only cross once. So we threw a lot of vocabulary at you. So if you need to take a second and soak that in, feel free to do so. We are going to look at a couple of examples with inverses today, though. So if you're following along in the book, this is from page 71. Again, we are in that orange book there. So if you want to look at that, you can. So basically, we've got a graph here. We don't know what the equation is, but we know that it is y equals f of x. And so what we're going to do here is we are going to explain first off why f of x is an invertible function. So if you're looking at this right here, if you draw any horizontal line through here, it is only going to cross one time. So right off the bat, so it passes the horizontal line test. And so we're going to say, so it's 1 to 1. And therefore, we'll have an inverse. So then the next thing that we're going to do, where's -5 here? Up 2. So the next thing we're going to do here is we're going to actually, 1, 2, 3, 4. So we're going to actually graph the inverse of this thing. So again, when we're graphing an inverse, we've got our reflection line right here in pink that Mr. Price is drawing. We've got this is y equals x that I've highlighted in pink. That if you pick any coordinate on this, that y is equal to x. And so to reflect across the axis here, if whichever way you go, if you measure to the right one, you say it's right one away from it, you're going to go down one here, because these should be the same distance here. So then the other thing that we're going to measure here, and there's two ways to think about this. That when you reflect it over a line, if this is the coordinate 3, 4, and this is the coordinate -5, 2, there's a couple of ways to think about this. If it's an inverse, x and y are just going to switch. So I'm going to graph the coordinate 4, 1, 2, 3, 4, up 3, and we'll end up in the same spot here. So then with this coordinate right here, -5, 2, we're going to flip x and y, and that's going to become to the 2, and then 1, 2, 3, 4, 5. There's a couple ways to end up at this. So with this being a reflection, these should look, give or take, the same, like shape-wise. So we've got -5, 2, we've got 3, 4, and you can look and see that those coordinates there are just the flips. So then when we're talking about the domain and the range of these, so for f of x here, we've got the domain and we've got the range here. So when we're looking at these, the domain, the furthest left that this graph goes is -5, which is an included point here. And then we've got 3, which is the furthest right here, and that's included. So just to make sure we're comfortable with all this notation, I'm going to do the range in set builder notation. So we've got y such that the lowest y value here is 2 is less than or equal to y is less than or equal to 4. You do not have to do it in set builder notation. I am just making sure that we are comfortable with it. And then for f of -1 of x, all that we're going to do is we're going to switch these two things. So the domain isn't going to be y still. It's going to switch to x. X such that 2 is less than or equal to x is less than or equal to 4. And then the range is going to be -5 to 3. And those need to be brackets, excuse me, for this right here. For that problem right there. So in a nutshell, to find a graphic inverse, all that you're going to do is you're going to switch the coordinates on x and y, and you should be good to go. So then, moving on to the last couple of examples here for today. So we're going to find some inverses algebraically. So the first function that we're going to do is f of x equals 4x minus 5. Now, we need to understand, currently we're looking at this and we're like, oh, wait, Mr. Price, there's not a y here. This f of x means y. This f of x is just a different way of saying y. So really, we've got y equals 4x minus 5. And so when you're finding an inverse, really there's two steps involved. So to find an inverse here, what we're going to first do is switch x and y. So this is going to become x equals 4y minus 5. And then the second thing that we've got to do is simply to solve for y. So now we want to get y by itself. So over here we're like, okay, well, to do that, Mr. Price, I'm going to add 5 to both sides to get x plus 5 equals 4y. And then to finish that off, to get y by itself, I would divide both sides by 4. So x plus 5 divided by 4, this is equal to the inverse function of x. So when you see that notation right there, that is how you mathematically say this is the inverse function of f of x. So we're going to look at two more of those and go from there. So then the next one we've got here, we've got y equals the square root of x plus 5. So then we're going to say, okay, the first thing we need to do is switch x and y. So we've got x equals the square root of y plus 5. So to get y by itself, we have to get rid of that square root. So we're going to square both sides here. We get that x squared equals y plus 5. And then because we in our math system like to graph equations when it's y equals, we're going to get y by itself there. To get that x squared, if we subtract 5 from both sides, x squared minus 5 equals y. X squared minus 5 equals y. But we want to indicate that that is an inverse. So we're going to say x squared minus 5 is equal to g negative 1 of x. Because again, this function was not listed as f of x equals. It's g of x. So we just need to make sure that we're paying attention to that. And so the last thing that we're going to do is we're just going to think about a problem real quick. Just kind of a good thinking question here. And so the question is, if a function f of x has x-intercepts at -3 and 2, so graphing that, so -3 and 2 here, and we have a y-intercept. I don't know why I'm graphing negatively. It is all good. 4. We want to know why this function is not invertible. So if we kind of sketch this function right here, I don't know if this is exactly what it's going to look like. Maybe it's a parabola, maybe it's not. We'll see. So we've got 0, 4. We've got 2, 0. We've got negative 3, 0. So think to yourself real quick, okay, why does this not have an inverse? Why is this not invertible? And think to yourself for a second and be like, okay. So here, I want to get into why the horizontal line test actually works. Why do we use it as a method? And so to do that, what we're going to do is say, okay, well, this doesn't pass the horizontal line test. So we're just going to go ahead and say that straight up. Doesn't pass HLT, the horizontal line test. It does not pass that. But let's say we tried to find the inverse here. So let's see. Instead of 0, 4, it would be 4, 0. So we're going to plot a point right there. I'm trying to do this in blue ink. I hope that it pops up with the black ink all right. We'll see if it works. If not, maybe I'll highlight it in pink. So then instead of negative 3, 0, we're going to do 0, 1, 2, 3, negative 3 here. And instead of 2, 0, we're going to do 0, 0, 2 there. And so now what we've got here is we've got a blue sideways looking parabola here. And so the reason that we can't call that an inverse function is because this sucker right here isn't going to pass the vertical line test. The inverse, if it doesn't pass the horizontal line test, the inverse will not pass the vertical line test. So whenever we're talking about this horizontal line test, really what we're saying is that if we flip x and y, then it's probably not going to pass the vertical line test. So I just wanted to do that quick thinking exercise with us. So that is all of the notes that I have for today on inverses. So if you all have any questions at all, please come into Zoom, shoot me an email, whichever way you like to communicate with me, and we can go over it then. But thank you all. Bye.